Assalamualaikum and greetings everyone. Today's topic is on properties of operator del. As you know, del is really a vector differential operator that only operates on a scalar field. Here we have a basic rule for the gradient or for the operator del. Let's say you're given A and B as a scalar fields. So item number 1, property number 1, del of A plus B is equal to del A plus del B. Property number 2, del of the product AB is equal to A del B plus B del A. And item number 3, property number 3, del of A over B is equal to B del A minus A del B divided by B squared. Now, if you look at all the properties 1, 2, 3, it is very similar to the property of differentiation, except now the result will give you a vector, even though you start with a scalar field A and B, but when you include del before the scalar field, the result will give you a vector. Okay, so that is vector differential operator del. As you know, it only operates on a scalar field, but if you want to operate it on a vector field, you need to add dot product or cross product. Okay, now let's look at the multi operations involving del, del dot, and del cross. As you know, if it's del only, it has to be a scalar field afterwards. But if you have del dot, then you have to have a vector field after the dot. And also, if you have cross product here, you have to have a vector field right after the cross product. But if it's only del by itself, what comes afterward should be a scalar, not a vector. Okay, let's say here you're given a vector function or a vector field f and a scalar function or scalar field small f. As you can see, f here is in bold, meaning that it's a vector. F here is not bold, meaning that it's a scalar. Okay, multi-operations involving del, del dot, and del cross is the first one. Well, obviously, we have more than this, but some of them is, let's look at item number 1. We have divergence grad f. Okay, so divergence, remember for divergence is del dot, and grad is del. So del f will give you the gradient of f. It's going to be a vector, and del dot a vector is going to be a scalar. So the result for this is going to be a scalar. Okay, because del is gradient. Okay, the result is a vector. Del dot is divergence. Okay, and the result is a scalar. Del cross is what we call curl, and the result will give you a vector. Okay, now let's look at item 1 again. Divergence grad f. So divergence is del dot, grad is del by itself, but of course you should have a scalar here. So the result del dot gradient of f is a scalar. Okay, item number 2, curl grad f. So curl of grad of f, and you remember curl is del cross and grad is del f. So here, when you take the gradient of a scalar, what you get is a vector cross with a vector. The result will give you a scalar. Sorry, the result will give you a vector. Okay, now item number 3, we have gradient of divergence of f. So remember, divergence is del dot, and you have to have a vector here, and then the gradient, and the divergence of f, del dot f, will give you a scalar. Remember, it's going to be a scalar. And then the gradient of a scalar is a vector. Gradient of a scalar is a vector. So the result here is a vector. Okay, item number 4, we have divergence curl of f. So curl of f is del cross f. So del cross f is curl of f. It's going to be a vector. And then divergence is del dot. So del dot a vector is going to be a scalar, because divergence will give you a scalar. So divergence of curl of f, the result is a scalar. And item number 5, we have curl of f. So curl of f is del cross f, and another curl, we take the curl of that. So curl of f is del cross f, and the result will give you a vector. Okay, so if you have del dot and del cross, del dot and del cross, what should come afterwards must be a vector. And del dot a vector is a scalar, del cross a vector is a vector. But if you have del by itself, what should come afterwards should be a scalar, and a del of a scalar, or the gradient of a scalar, will give you a vector. So those are some of the multi-operations involving del, del dot, and del cross. For examples, I'm going to save that for our live class. Thank you.